All right, so this is a note. This is some a video about the notes on trigonometry. So this is like an introduction to trigonometry. We're going to start with some stuff that we did last unit on talked about similarity and congruence. We got two triangles here. All right, we got two right triangles. Right, they both have right angles, and they have another pair of angles that are congruent. Just that, we know that the two triangles are, at the very least, similar by the angle-angle similarity theorem. They could be congruent too, but we don't know what any of these numbers, actually, what A1, A2, and C2, C1, what any of those are. So, we only know right now that they're similar. Given that, we get the following proportionality statement. Just from the fact that they're similar, we get that, well, the ratio of A1 to A2 is going to be the ratio of B1 to B2, C1 to C2. Now, we can take these, and I'm just going to show you, I'm going to give you one example. I'll just take these two, right? A1 over A2 equals B1 over B2. And we can do a little algebra. Do our cross multiplying, right? So we get A1 times B2 equals A2 times B1. Now we're going to do a little division. We're going to divide both sides by B1 times B2. We can do that. As long as we divide both sides by the same thing. What happens? Well, these B2s cancel out, these B1s cancel out, and we're left with A1 over B1 equals A2 over B2. I'm going to write that over here. That'll be our first equality over here. A1 over B1 equals A2 over B2. If this doesn't really totally make sense, it's okay. I just want you to see it. I'll talk about it, what it means in a minute. I could do that with each pair. Like I could do that with A1 over A2 equals C1 over C2, and I'd end up with A1 over C1 equals A2 over C2. And I could do it with B1, B2, C1, C2, and I'd end up with B1 over C1 equals B2 over C2. What does this mean, though? This is like a lot of fancy algebra. I don't really care because we're not going to spend a lot of time doing this kind of stuff. What we care about is what it shows us. It shows us that in any right triangle with a given acute angle, so here's my acute angle, right? Here's my acute angle here. Doesn't matter how big the triangle is, it's always going to be the case that the ratio of the one side, any one side to any other side, is going to stay the same. So the ratio of one side to another side stays the same. So the ratio, if we think of it this way, we've got a right triangle here. The ratio of the short leg to the hypotenuse is going to be the same, like that's A1 over C1, is going to be the same as the short leg to the hypotenuse in this right triangle. As long as they have the same acute angle, they're going to have the same ratio of short leg to hypotenuse, or long leg to hypotenuse, or short leg to long leg. Any of those. Okay? Now, this turns out to be really useful, and it's going to take a little bit to see why. So we're just going to do a little quickie investigation here. So what you're going to do on your paper is mark a point. You've got the horizontal line and a vertical line, and they meet at a right angle, and you're just going to take my word on it that that's a right angle. Okay. Pick a point, anywhere on the horizontal line, and just mark it. And I'll use that one right there. And any point on the vertical line, and I'll take this one right here. Okay, so those are my 2 points. Now I'm going to take my protractor, you should have a protractor too, and I'm going to connect those 2 points using the straight edge. Don't draw it freehand, please. Okay, take this line, I'm going to mark it off. Now I'm going to label the sides of the triangle in the following way. So here's going to be my angle. This is going to be my angle right here. We'll call it theta. That's what that means. That symbol is theta. It's a Greek letter. Okay. We'll label the 3 sides in the following way. The side that's across the vertical side here, which is across opposite the angle theta, we'll call that opposite. Now the side that is next to the angle, but is or adjacent to the angle theta, we'll call adjacent, the one that isn't the hypotenuse. And then the hypotenuse we'll just call the hypotenuse. Okay, so you should have something that looks like this. Your triangle may be different, your points may be in different places, whatever, however you did it. But you should have opposite over here, adjacent here, and hypotenuse there. Okay. Now, step 4, we're going to measure the angle in the lower left of the triangle. That's our angle theta. And we're going to write that in the box here. So I'll get my protractor out. You can follow along with me if you're not remembering exactly how to use a protractor. I'll put the circle part over the dot, over my point here, the vertex of the angle that I'm measuring. I'll make sure that this line, the black line on the bottom, is in line with this side of the triangle, side of the angle. And then I will look up the other side of the angle and see where it intersects. So it intersects right here with my protractor. Now I always measure starting at 0, so going up from 0, not down from 180. Up from 0 I get that it's about, I'm going to say 19 degrees. And try to get it as precise as you can. I might even have said it was 18.5, but I'll just go with 19. 19 degrees. Okay, step 5. Measure the lengths of each side of the triangle and record those measurements in the box on the right. So I'll measure them. Does it matter if I use centimeters or inches? No. However, centimeters are smaller, and so they tend to be more accurate. Alright, so I've got centimeters. I'll do that. That's in the inside of my protractor. And so I get 3.5, 3.6, let's say 3.7 centimeters. My adjacent side, it's a little long. Well, there's 10 right here, so just do this, and then how far? 10.2 centimeters. And then I'll measure the hypotenuse here. I could get a ruler if I wanted to, I'm going to, and what do I get? 10.8, let's say. Okay, got my measurement. All right, now flip the paper over. Okay, this is going to be about sine, cosine, and tangent. We're going to use those numbers that we just did to find the sine, cosine, and tangent of the angle. So the sine of an angle is equal to the length of the opposite side divided by the length of the hypotenuse. Cosine, the length of the adjacent side divided by the length of the hypotenuse. And tangent, length of the opposite side divided by the length of the adjacent side. So these are 3 things we're going to know. There's an easy way to remember this, sort of easy. It's called SOHCAHTOA, S-O-H-C-A-H-T-O-A, and that stands for sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. I'm going to use that now down here. So, I'm going to use the measurements on the previous page to find sine, cosine, and tangent of the angle that we just measured, and of what we did, over here. Okay. So my angle I said was 19 degrees. So sine theta is going to be the opposite length over the hypotenuse. So the opposite length was 3.7 centimeters, and the hypotenuse was 10.8. I'm going to write that. So after you find the ratio, find the decimal to 4 decimal places. So I'll take just for here, 3.7 divided by 10.8, and I get 0.3426. Okay, 4 decimal places. Now, adjacent over hypotenuse. My adjacent side was 10.2. My hypotenuse was 10.8. I get that as a decimal, 10.2 divided by 10.8, 0.94, repeating, 9444. And then finally, tangent is opposite over adjacent. Opposite side was 3.7. Adjacent side was 10.2. Go back. 0.3627. Okay, now of course your numbers are going to be different because you used a different angle, and you had different lengths of your sides. Now we're going to check these answers using a calculator. Well, what does that mean? Well, your calculator is equipped to calculate sine, cosine, and tangent. Again, our angle is going to be 19 degrees. And we can calculate sine, cosine, and tangent, and we should get these numbers that we got up here. I have no idea because I'm just doing this right now, blindly, so hopefully it works out. One thing you need to do on your calculator, this is really important with the TI calculators, is check to make sure you're in the right mode. So press the mode button, press mode here, and go down, and mine is not in the right mode. If you go down to this third line here, it says radians, degrees. You want degrees to be highlighted, not radians. So go to degrees and then hit enter. Right here, this one. When you do that, now degrees is highlighted instead of radians. And to get out of that screen, you just hit second mode. And now we can do our calculations. So what we want to know is what sine theta is. So sine 19 degrees, what is that? So sine 19, 0.3256. 0.3256. Now what did we get? We got 0.3426. Not too far off. Not too far off. Let's try this one. So cosine 19 degrees. Cosine. So I hit cosine 19. Right, cosine is right there in the middle between sine and tangent. And enter 0.9455. 0.9455. We got 0.9444. Not too bad. Now tangent is so we're going to do tangent 19 degrees. So hit tangent here at 19, close parentheses. You get 0.3443. 0.3443. Up here we got 0.3627. I'm guessing that maybe this opposite measurement was not as accurate as I'd hoped. But anyway, that's it. So that you can see how we get these numbers, where these numbers come from. And then you can also, I want you to see, this is how it works on the calculator. And what we'll be doing mostly is doing these on the calculator. Okay.